but rather will understand a very chemical phenomenon or a very chemical new understandings. That's why I have used these examples. So very simple. The first one is the students can solve this problem in seconds. Yet I am using, so just after finishing these two examples or explanation, you will understand what is that particular line, why it is happening like that. This will form these things. This is pH. The new carbohydrate will be generated. pH, pH. So, okay, so I had some mistakes. So basically, it will be Me, means Me, Me, and Me. Okay, now between Me and pH, which group is going to migrate here? Because it's a generation of carbocations, means it's a some kind of disaster happened inside the molecules. So we have to relax that. We have to get relief from that. That's why among Me and pH, one will migrate. Who will migrate? That has more tendencies to stabilize this carbocation or positively charged. That will migrate. So among Me and pH, which has more tendency to stabilize or more power to stabilize this positive charge? pH. Why? It has, because it is electron rich system. So that's why we use a term, the migrating aptitude of pH is more. Now the analysis, why the migrating aptitude? Because it's migrating to a positively charged center that is not stable. As this is migrating to a positively charged centers, if it has aptitude or better aptitude to stabilize that, better ability to stabilize that, then only it will migrate. pH being electron rich than Me, it can stabilize these things far better. That's why this pH migrates. So this is the main reason between the migration aptitude. So now pH migrates there. We have this pH, Me plus, this is double bond O, sorry, this is OH, and after minus H plus, it will be these things. pH. Okay. Again, I'm starting from the beginning because of some mistakes and technical faults. Because as everything is going to be recorded, so it should be clear up. Just please wait, just few seconds, then we'll start again. Okay. So if we protonate them, pH, now there will be a generation of carbocation, OH, Me, and pH. Then there is a migration will happen because now which group will migrate? The group that can stabilize the carbocation more, that will migrate. Now among Me and pH, the carbocation stabilizing efficiency is more in pH because it is electron rich. So pH being electron rich system, and stabilize the carbocation more. That's the reason between the migration aptitude of pH more than M more. This is OH. Now this is pH. The pH migrates here Me minus H plus. Yeah. So students, you can visualize this example by a fantastic phenomenon. We know that any charge particle is not stable. So we see a charge particle generated inside the ring means it's like a disaster in the systems, in the molecular system, like a disaster. So now to whom you will send, if there is a disaster naturally to whom you will send, that have better disaster management ability, to whom it will send. So now Me and pH, the pH have this better disaster management ability. To what? To stabilize this carbocation. It's a generation of these carbocations. You have to stable that, make stable that. That's why the pH migrates. This is the reason. So you can visualize by normal or daily life examples also. And for the next case, this is double bond O. This is CO2 and this is pH. So what will happen? So what we'll discuss earlier, we are going to see how is that explaining these things. This is CO2 and pH. And we know that this carbocation will generated OH, ET, and pH. Now, so we previously considered that pH has better stability, better carbocation stabilization efficiency or power. That's why pH would migrate. If now pH migrates, then what will happen? Let us think in first case molecule select. Okay, now I will just migrate the pH from here to here. Then I will have initially good results. If pH migrate, then see what happens. This is OH and this is pH. We have a new carbocation here. Now this is carbocation destabilized, the initial state after the primary stabilizations of carbocation. So what we left behind? The left behind highly unstable state. Highly unstable state means the last, at last, CO2 cannot tackle such unstable environment, such unfavorable environment. Favorable environment. So what happens? So when pH move to the carbocation centers, it's give a duty to CO2 okay, now take care of the new carbocations. I am going to stabilize that. But when it stabilizes that things, CO2 has no longer that power. So it is highly unstable. That's why it cannot happen. So here, the first, what happened? That now pH is telling that okay, so I know you don't have the ability to stabilize carbocation. A2 migrate. The latter stage, I will take care of that. I will stabilize is that. That's the beauty of this chemistry. This is the molecular language. This is the molecular talking. That's why, in spite of bearing electron, in spite of having electron destabilizing tendency, CO2 it is migrating there, and the last carbocationic part will be well controlled or will be under control of pH. That's why here, though this is the electron deficient or electron destabilizing moiety, it will migrate. So This is pH, CO280, OH. This is minus H plus. So this is the system. So it's not always true the electron rich moiety or the moiety having more migrating aptitude is going to migrate. This is not always true. We find in the case the group having low or poor migrating aptitude is going to migrate. It depends on the situations. Molecules always work as or along situations or like situations. Yeah, that's why the migrating tendency is like that. I hope you have greatly enjoyed these topics. And one thing I add, each functional group in a molecule talks with each other. That's why it was a demand by pH or it is a command by pH. You go there, I will take care of rest of the things. That's why the migration of CO2 it was first.